Now, way back in chapter 1, we studied even and odd functions, right? And so in this section, we are going to talk about the even and odd properties of trigonometric functions. Now, let's think back. What does it mean for a function to be even? A function is said to be even if its graph is symmetric with respect to the y-axis. This also means that evaluating f of negative x results in the same quantity as evaluating f of x. F of negative x is equal to f of x. Notice that plugging in a negative quantity of x would give you out the exact same value as if you were to plug in the opposite of that. What does it mean for a function to be odd? A function is said to be odd if its graph is symmetric with respect to the origin. This also means that evaluating f of negative x results in the opposite quantity as evaluating f of x. In other words, f of negative x is equal to negative f of x. Plugging in negative x will give you out the opposite of plugging in f of positive x, or evaluating f of positive x. How does this relate to our trig functions? Well, cosine and its reciprocal secant are both even functions, while sine and its reciprocal cosecant are odd functions, along with tangent and its reciprocal cotangent. So we have the cosine of negative theta is equal to the cosine of positive theta, and its reciprocal secant of negative theta is equal to the secant of positive theta. Cosine and secant are even trig functions. Our odd trig functions, sine of negative theta is equal to negative sine theta. Similarly, its reciprocal, cosecant of negative theta, is equal to negative cosecant theta. And tangent as well, the tangent of negative theta is equal to negative tangent theta, and the cotangent of negative theta is equal to negative cotangent theta. So sine, cosecant, tangent, and cotangent are odd trig functions. So let's think about this graphically. Let's look at a couple of our angles. If I were to pick one angle, I don't know, we'll keep it simple here with pi over 3, which is in the first quadrant. Here I have the angle positive pi over 3. We'll call that one theta. And this angle down here would be negative theta, right? We've traveled through the exact same arc, but just in the negative direction. And if you were to compare the ordered pairs, x and y, you might notice that the x-coordinates are identical and the y-coordinates are opposite of each other. So notice, if we were to evaluate the cosine of negative pi over 3, that would be the exact same thing as the cosine of positive pi over 3. They share the exact same x-coordinate. And because secant is just the reciprocal of that, the same thing goes for secant. As far as sine goes, sine corresponds to the y-coordinate. Notice that the y-coordinates of these two angles are opposite of each other. Well, that means that the sine of negative theta is equal to the opposite of the sine of positive theta. And because cosecant is the reciprocal of sine, we have the same property. Tangent. Tangent, we find tangent by taking the ratio of the y-coordinate to the x-coordinate. Well, notice in this case, I have a positive divided by a positive, which gives us a positive for the tangent of positive theta. And for negative theta, I would have a negative divided by a positive, which would be a negative, right? So those are going to be opposites of each other as well. The tangent of negative theta is equal to negative tangent theta, and that means its reciprocal is also going to have this odd property. So this can help us when we are trying to evaluate a trig function of some negative angle when we are given a piece of information about the positive angle. So, for example, use the trigonometric function to evaluate the indicated functions. In this case, we are told that the cosine of theta is equal to negative 3 pi over 4. And we are now asked to find the cosine of negative theta, so the opposite angle. Well, we know that cosine is an even function, and because cosine is an even function, that means that the cosine of negative theta is equal to the cosine of theta. Well, what's the cosine of positive theta? Negative 3/4. Therefore, we have our answer. Find now the secant of negative theta. Well, secant is also an even function. We know that the secant of negative theta is equal to the secant of positive theta. Well, let's take a look. We know what the cosine of theta is, and hopefully we recall that secant is the reciprocal of cosine. The secant of theta is the equivalent of 1 divided by the cosine of theta. So if this is equal to 1 divided by the cosine of theta, that means I need to take the reciprocal of that quantity. That's 1 divided by negative 3 pi over 4, which is equal to negative 4/3. Right? So we are just using these even and odd identities to help us in finding some more relationships about our trig functions and angles that might be opposite of angles that we know. Let's look at one more here. Okay, the sine of negative theta is equal to 3/8. This says find the sine of positive theta. Well, sine is an odd function. Therefore, we know that the sine of negative theta is equal to negative 1 times the sine of theta. So, that means sine of theta is equal to negative sine negative theta. Notice that we have just manipulated this equation right here to solve for sine theta. To solve for sine theta, I would multiply both sides by negative 1. Sine theta is equal to negative 1 times the sine of negative theta. And we have this quantity. The sine of negative theta is equal to 3/8. Therefore, the sine of positive theta is equal to negative 1 times 3/8, or negative 3/8. Find the cosecant of theta. Well, cosecant is an odd function. We know that the cosecant of negative theta is equal to negative 1 times the cosecant of theta. So we have this equation. In order to isolate cosecant theta, we could multiply or divide both sides of the equation by negative 1, giving us cosecant theta is equal to negative 1 times the cosecant of negative theta. Well, we don't have cosecant, but we have sine. And hopefully we recall that cosecant is the reciprocal of our trig function sine. In other words, I can replace cosecant negative theta with 1 divided by the sine of negative theta. Well, this is negative 1 times 1 over the sine of negative theta. That's the reciprocal of sine negative theta, the reciprocal of 3/8. So that's negative 1 divided by 3/8, which is negative 8/3. All right, and so there you have it, your even and odd properties of our trig functions.